Alright, in today's video we're looking at one of the experiments from the Separating Substances unit in Grade 9 Advanced Science. This time it's called paper chromatography. You may have done something like this in earlier years, middle school or even elementary school, or if you've ever done a tie-dyeing of a shirt, you've done essentially the same idea. So you were given in an earlier lab something to take home to do this experiment. You were given some filter paper, one of which has already been prepared. So you can, if you got that, you'll tear that off like that. It's been prepared. It began with a piece of filter paper that we use scissors and we cut to a fine point. Okay, so you have a long filter paper cut to a point. We then used a pencil, not a pen, and we drew with a ruler a straight line like that near the bottom of the filter paper above the point. So on that line, right in the center of that line, the lab assistant applied some black ink. So let me show you what she did. We took a bottle of black ink and we poured some of that ink into a beaker, and a capillary tube was used. The capillary tube was dabbed into the ink, and then a small dot of ink was placed right in the center of the line on the paper. Maybe a couple of applications. So you want to prepare a small but concentrated dot of ink. So try to make it as small as possible. This is about as big as you'd want from a capillary tube. And then let it dry for a moment or two. You might even wave it in the air to let it dry. And then you can apply another dot in exactly the same spot because you want it to be concentrated. So you want to get a good amount of the ink in the middle of the line. So that was prepared for you by the lab assistant, and you have one like that. If you were at school, you would take a 50 milliliter graduated cylinder. The cylinder has to be wide enough, or this one's a little bit too narrow. We usually use narrower filter paper, so that has to be narrow enough that that can go inside. So I'm going to just trim this a little bit. When we do this in the lab, we usually use narrower filter paper, but I'm going to just trim this a bit on the edge to make it fit into the work. That fits nicely now. And then what you would do is you would lower the filter paper into the cylinder. I've got about 10 milliliters of water, just tap water. I'm going to lower that until the tip of the paper is in the water, but I don't want the ink on that line to be in the water. I want the ink to be above the water, and only the tip of the paper will go into the water. So I lower it, lower it, lower it, and I think I need to trim it just a bit more. Well, can I get it down there? There you go. So now the tip of the paper is in the water. I'm going to just fold the paper over the edge like this. I should have trimmed that paper a little bit more so it wouldn't be all crinkled like that, but that's pretty good. So now the tip of the paper is in the water, and the water is starting to climb the paper, and when it climbs it will eventually hit the ink dot. Now anything in that ink that's soluble in the water will then be carried with the water up the paper. And if there is more than one thing in the ink, they can travel up the paper at different rates. Some will travel faster, some things will travel slower, and so as they travel they'll separate from each other. Remember, this unit is about separating substances, so here we're going to separate the components, if there are any, in black ink. And we're using water as a solvent. Now, if the ink is not soluble in water, if there's nothing in the ink that dissolves in water, then the water will just hit the dot, the water will keep moving, and the dot will stay where it is. So the ink has to be soluble in water, or some parts soluble in water, for this to work. If water didn't work, if nothing was soluble in water, then you could try a different solvent. You might use alcohol. If you have some at home, you could use rubbing alcohol from the bathroom. So that's what we would do in the lab at home, at school. You've got your filter paper that's already prepared. You'll need to find a container. This glass here that's a little too short. Okay, so I've got a taller container here. This one will work. It's a little bit too wide, but that's okay. Better that it's long enough that when I dip this in, see how it's going to have a long way to travel up the paper. So I can dip that in. I don't want the ink to get in the water. I've got about a centimeter or so of water in the bottom of the container, and I'll just fold it like that over the edge of the glass so that it stays there. And now I'm going to let the water climb up, and it'll climb up, and anything that's soluble will dissolve in the water and possibly separate as they travel up the paper. When you're done, you'll take a picture of this. You can label at the top, if you'd like, black ink in water, and take a picture of what you see at the end. Now, you've also been given several other pieces of filter paper. You may have to tear them off, or you can grab some scissors and you can just cut the very end like that. And now what you should have are enough filter paper to have 3 more strips. So let me just tear that as well. Now I've got enough paper for 3 more strips. I'll take that one more time, and with my scissors I'll cut the very end to make that fine tip. I didn't bring a pencil with me. I'll draw a pencil line across. It has to be pencil because the graphite that's in pencil will not dissolve in the solvent. So don't draw a line with ink because, of course, the ink may dissolve and travel up your paper. So let's pretend I've got a pencil line there. You probably have other sources of ink at home. So I've got here a red felt pen, a blue felt pen. I've got a couple of just normal writing pens, a blue and a black. And I've got a Sharpie here that's blue as well. Now I know this Sharpie, it actually says permanent on it. These other ones are not permanent. Okay, no, do not use more than one permanent ink. So you're going to want to use 3 other experiments. We're going to set up 3 others. So I'm going to use the blue Sharpie. Again, let's pretend I've put a pencil line across there. I can apply a small dot, and then a same space again and again. I would want to wait a few seconds in between to let it dry. I want a concentrated but small dot of ink. And now this one's ready to go. I could do the same thing in another beaker, another glass at home, a nice tall glass, to see what happens with the ink from this pen. If you want to be a little extra creative, you can use other solvents than water. As I mentioned, you might use rubbing alcohol if you have some rubbing alcohol at home as another solvent, okay? But if you're going to use something like that, maybe just double check with your parents that that's okay. So in the end, you're going to have 4 filter papers that are developed. Okay, they've all developed, they've separated or not as the water traveled up. You want to pull it out of the water before the water reaches the top of the paper. So when the water reaches near the top, about maybe half a centimeter or so from the top, pull the paper out of the water will stop climbing. At that point, you can lay them down, you can label them. This one was black ink in water, this one was a blue Sharpie in water, maybe a red felt pen in alcohol. You can try different combinations and take a picture of your chromatography results, and you'll upload that on Google Classroom. One of the possible components in your sludge mixtures in our experiment coming up is black ink. Some sludge components may have some black ink in the sludge, in which case this experiment would give you some evidence that you have black ink in your sludge. So I hope that helps. Do the experiment at home. It should take about 20 to 30 minutes for the water to climb your filter paper, so budget that time. Don't walk away from it. You got to pull it out of the water before the water reaches the top of the filter paper.